Hey guys, today we're going to talk about equations of circles. So we're going to be looking at circles in a more algebraic sense and how we can get some equations to represent them. So in order to do this, we're going to focus on first a circle that's centered right at the origin, and we're going to make an equation to represent. So let's say we have this circle, and the equation we're going to have to represent is going to involve our radius. So we'll say we're centered at the origin, and we'll go to a point that we'll call xy. And xy could be any point on the circle, but for now it's going to be just this point. So if we want to make an equation to represent this radius here, we can kind of break this into a nice little right triangle. Down here, this would be the value, or one of the legs of your right triangle. This would be the other leg. And the distance here for this would actually end up being x, because you're like x units over to get to that point. And the distance, or the length of this, would be y, because from the origin to this point you're going y units up. So if we were to do a little bit of Pythagorean theorem here, you would have x squared plus y squared equals the radius squared. And this equation represents this circle centered at the origin. Now, not all circles are going to be centered at the origin, so we're going to take this one step further, really applying the same concept, but we're going to move that center. So let's go ahead and take away our circle. And let's stay in the first quadrant here. X and Y, let's say we have a circle, my best circle, and we're going to be centered at some random point. And the point we're going to use for this, we're going to call it h, comma k. It could be any point. It doesn't necessarily have to be in the first quadrant. It can be anywhere. We're going to call it hk, and we're going to do the same thing. We're going to make a little segment here that's going to connect to a point, and we'll keep calling that xy. And this is going to still represent our radius. If we do the same thing that we just did centered at the origin, if we make a nice little right triangle here to find that radius, this bottom part is no longer going to be the length of x, it would be the length of x minus h. And this little vertical segment here is going to be the length of y minus k. You also can think of this like distance formula when we get to making the equation. It's like the change in your x-coordinates, the change in your y-coordinates, the difference between them. Now if we did Pythagorean theorem here, we're going to have x minus h squared, that's one leg, plus the other leg squared, which is y minus k squared, and that's going to equal the radius squared. And then there you go, this is going to be our standard form of an equation for a circle. And I said this is kind of like distance formula, because if you took the square root of both sides, it would be very much similar to distance formula, just different variables, subtracting your x-coordinates, subtracting your y-coordinates, and you would equal the radius. We're going to keep it as squared though here. So this form is the standard form for a circle. And what's nice about being in this form is if we have equations written in this form, like let's say we have, x minus 5 squared plus y plus 2 squared equals 16. If we're in this form, we're right in the form, then we know, just from being in this form, the center is going to be, well, the center is hk, and in this form you have minus h minus k, so minus h, we have minus 5, so it's going to be 5, minus k, we have plus 2, which is like minus negative 2, so our center is 5, negative 2 here. And we're equal to the radius squared, so we're equal to 16, so the radius for this blue example, well, that would be the square root of 16, which we should know is 4. So our radius would be 4. So in this form, you can pull out the center, you can pull out the radius. Once you have the radius, you can get the diameter and do a lot of things with that. So being in this form gives us a lot of information about the circle. So we're going to take a couple of examples of given information, like given these, and trying to write in the form. And then we'll build off that a little bit more today. So our first example, we are going to have a circle that has a center at -8, 4, and has a diameter of 14. And we want to make an equation in that standard form. So in that standard form, again, it's going to be x minus h squared plus y minus k. That quantity squared equals r squared. H and k are your center of the circle, h comma k, and x and y represent any point on the circle. So we know we have a center of negative 8. So let's say we have a center of negative 8, negative 8, 4, sorry. When you put in the negative 8 here, minus negative 8 becomes plus 8 squared. And it's going to be y minus 4 squared equals your radius squared. So your radius would be half of 14. Your radius is 7 squared is 49. So this would be our equation in standard form to represent this circle here. And now let's do one a little bit different. We're going to be given some different pieces of information. Let's say we have a circle with a center at 3, 2, and we're given the point 6, 6 lies on the circle. So we know 6, 6 is a point on the circle. And we want to write an equation in our standard form. So x minus h squared plus y minus k squared equals the radius squared. So we need to think of what we know. We know the center. So we know it's going to be x minus 3 squared plus y minus 2 squared. We don't know the radius though. But we do, however, have a point that lies on the circle, and we have the center. So to find the radius, you're really just going to, you can use distance formula if you want. I'm going to say r for radius, but the distance would be the square root of, well, the difference in your x coordinates. So 6 minus 3, which is 3 squared. 6 minus 2 would be the difference in your y coordinates, so that would be 4 squared. You might notice if you were to sketch this out, it actually makes a nice 3, 4, 5 triangle. So the square root of 9 plus 4, 9 plus 16 is 25. So our radius should be 5. So here your radius squared is going to be 25. You want to make sure that's the radius squared there. So this would be standard form of this circle. You can always be given different pieces of information, like maybe you're given, for example, you might be given of a circle, you might not be given the center, but you might be given 2 points that are part of the diameter, and you want to make an equation. Well, then for that, you would have to find the distance between them to get the length of the diameter, take half of that to get your radius, and you can do the midpoint formula to find out your center, because the midpoint of this segment would be the center. So you have to kind of figure out what you need to find and how you can get there. All right, we're going to do one last problem, and it's going to be, if we're not in this form, how can we convert into that form to find these missing properties of a circle. So our last one, let's say we have this form right here. We want to find the center of this circle, and we want to find the radius. And we're going to look like this. We have y squared plus 33 equals negative x squared plus 14y. Clearly we're not in the right form to be able to pull the information out. But we can convert this into the right form. We just have to do a little bit of work. So let's go ahead and we want to set it up so it's x minus h squared plus y minus k squared equals r squared. And also on a side note, if you're left with x squared like this, that would be like having x minus 0 squared. So if you have just x squared, that means your h is 0. So keep that in mind. That might pop up here. So we're going to go ahead and let's get all of our variables to the same side. I'm going to bring the x squared over. So x squared plus y squared. I'm also going to bring this 14y over with us. Minus 14y. And we can put the 33 over to the other side. That's fine. So here we're really close to being in the right form. We have the x squared, we have a y squared, we have this term that's kind of throwing us off. And well, we have a negative over here. Can't really have a negative radius for it, for what we're working with. So the question is, how can we turn this into this form? The x squared is okay. It would just be x minus 0 squared. But how can we turn this into y minus something squared? And to do this, we need to think way back to Algebra 1. We're going to do something called completing the square. So here we're going to complete the square. If you don't remember how to complete the square, if you have, in this case, ay squared plus by, and you take b over 2 and you square it, you add that to the end, and it'll make it a perfect square. So what we're going to do here is we're going to take the negative 14 divided by 2 and square it. And what that becomes is negative 7 squared becomes plus 49. So we're going to add 49 to the left side of the equation. We're also going to add 49 to the right side of the equation. When you add 49 to negative 33, you end up with 16. The whole purpose of doing this, completing the square, is this little trinomial here, ignoring the x squared, we can represent this as, well, we can represent that as y minus 7 squared. And that would equal 16. You can go ahead and multiply this out if you want to, but you're going to find that it equals this. That's the whole purpose of completing the square. And by doing this, by using completing the square, we've now made an equation that's in this form right up here. If we want to know the center of this circle, well, the center is going to be x minus h. Like I said, h would be 0 here. Then our y coordinate is y minus 7, so it's going to be a positive 7. This is our center. And to get our radius, it would just be the square root of 16. So the radius equals radical 16, which we hopefully know is 4. And our job is all done here. So sometimes you have to convert. It's not quite as easy as converting a linear equation. Using completing the square, that will be really useful in getting everything set up so we're in this nice form up here. Alright, that's all we have for today. You can go ahead and try some of these on your own, get familiar with this form. Have a nice day, guys.